Good day, everyone. We are the group of Papa, and we will be presenting the three major emerging technologies: the gene editing, robotics and automation, and nanotechnology, along with the ethical issues, global laws, and industry impact of each. Anyway, I'm Mays Orokai, and together with my group, Prince Bergernia for gene editing as well, and Pans Lance for robotics automation and then Saviliana for nanotechnology. So this presentation will make us or help us to understand not just how this technology work, but how they affect society and human ethics. So let's start in gene editing or the CRISPR-Cas9. Gene editing is also known as genome editing. It is a set of technologies that allow scientists to modify the DNA of living organisms. Unlike other engineering methods that randomly inserted genetic material, modern gene editing is highly targeted. CRISPR works CRISPR works like a find and replace over DNA, letting scientists to add, remove, or modify precise sequences. So, meaning to say that gene editing gives us the power to change life at its smallest level, the DNA. So, this process relies on engineered enzymes called nucleases, acting like as molecular scissors to cut DNA. So, the major gene editing tools include the CRISPR-Cas9. It is the most popular, fast, and cheap and accurate tool. Second is the talents or the transcription activator like effector nucleases and the ZFNs, the zinc finger nucleases. So these tools allow scientists to perform precise DNA surgery. So next is the core service. The first core service is the medical applications. CRISPR provides groundbreaking treatments for genetic disorders such as sickle cell anemia and muscular dystrophy. A major example is the Vertex Pharmaceutical 2023 CRISPR therapy, which successfully cured sickle cell patients. So for governing laws is WHO Human Genome Editing Guidelines by 2021, and the impact is it is revolutionized medicine but raises issue but about cost and equal access. So CRISPR can cure diseases that were once untreatable but not everyone can afford it. So second core service is the agricultural automation. In agriculture, CRISPR enhances crop resilience and nutrition. A well-known example is the Japan GABA enriched tomato released in 2021, which promotes relaxation and health. So the laws is the FAO biosafety and GMO regulations. The impact of it is to help food security but may harm biodiversity. And so gene editing can help feed the world if used responsibly.
So, core service C, environmental engineering. CRISPR gene drives can control vector-borne diseases by modifying or eradicating harmful species. So, example of this is the Target Malaria project that uses CRISPR to sterilize mosquitoes to prevent malaria. So, its governing laws is the United Nations Cartagena Protocol on Biosafety, and its impact is it protects human health but may disrupt ecosystems if misapplied. So this technology can save lives, but it might also disrupt the ecosystems or nature. Core service research and knowledge dissemination. CRISPR accelerates molecular biology research, enabling scientists to model diseases and study gene function. Example of this is CRISPR modified mice used in cancer research at Harvard Medical School. Governing laws is National Institute of Research Ethics guidelines, and its impact spans global biomedical knowledge while requiring transparent data sharing. Core Service 5, bioethical oversight and advocacy. So global regulatory boards monitor genetic research to prevent unethical human genome modifications. So example of this is the UNESCO International Bioethics Committee of 2023, which enforces ethical research policies. Governing laws is the UNESCO Universal Declaration on the Human Genome and Human Rights of 1997. Impact of this is it promotes responsible innovation and ensures scientific accountability. So, code of ethics and professional conduct. So, biotechnologists and researchers have a duty to conduct genome editing research with honesty, accountability, and respect for human rights. So, some of this is scientists undergoing institutional ethics review before performing gene editing studies. So, the preamble is genetic engineering must be conducted responsibly, ensuring scientific progress aligns with societal values. Um, Number one, general ethical principles. Act with honesty, respect for life, and non-maleficence, professional responsibilities, maintain confidentiality, inform consent, and research integrity. Number three, professional leadership principles, encourage collaboration, mentorship, and ethical awareness. Number four, compliance with code, so follow World Health Organization and UNESCO ethical frameworks. So here is a YouTube video for code of ethics and professional conduct.
It's a slippery slope. I've worked in the field of reproduction and fertility treatment for over 30 years. I've seen many uses of this technology that makes me feel uneasy.
I think we need to think about science more like a garden of forking paths. So, some of those paths are going to lead to undesirable consequences, but if we cut those off at the root, we're also going to close off all the paths that could lead to the good consequences.
Welcome to Doha Debates. In each episode, we present opposing sides of an urgent issue and search for common ground.
We will link this YouTube video in this recording since it is 36 minutes long. So, part four, industry impact and takeaways. So, international collaboration and challenges. World Health Organization, UNESCO, and global laboratories collaborate to standardize genetic research, legalization, disparities, and moral beliefs across countries challenge universal policymaking. Future trends, integration of AI with gene editing for predictive DNA modeling and precision medicine, statistical reports, World Health Organization 2024 reported over 200 clinical trials utilizing CRISPR technology worldwide. Demo is a simulation video showing CRISPR DNA copying mechanism and correction process. So this includes global CRISPR maps, research graphs, and charts. So here is another video commercializing CRISPR.
Talk to us about this new program and what the impact would be.
Hi, Emily. We are so excited about this program. At the Innovative Genomics Institute, we launched the WISE
Talk to us about this new program and what the impact would be.
Hi, Emily. We are so excited about this program. At the Innovative Genomics Institute, we launched the WISE program, Women in Entrepreneurial Science. Founded by a wonderful female entrepreneurial philanthropist, we have an incredible opportunity to recruit the best female entrepreneurs to the Institute, give them a head start to get their ideas launched, and then found companies off of those ideas. It's an extraordinary opportunity. I'm delighted to be part of it.
Why do we need more women in biotechnology in particular?
I'm a big believer that the best science gets done by a diverse team. We have to have people from all walks of life contributing to the future of biotech. In genome engineering with CRISPR technology, we've seen over the last decade the extraordinary advances made, both on the innovative side and also on the applied side. And I think that going forward, we just want to have the most the largest opportunity to recruit people from everywhere to come into this field and work on opportunities in genome editing.
What's your assessment of where we are at this phase of the pandemic, moving into hopefully post-pandemic, and the role that CRISPR and gene editing will play in preventing the next pandemic from happening?
CRISPR is such an extraordinary technology. I think, as you know, it came out of a study of a bacterial immune system. So it naturally works in nature as a way of protecting cells against viral infection. And going forward, we're using it not only as a way to detect the presence of infectious agents, but also to use it to make the kinds of changes in the genome that could be protective against future infection. I think those are the two ways that we'll see CRISPR having an impact in the future to prevent the kind of pandemic that we've just been through.
Now, there's been some controversy in the CRISPR world recently. Berkeley recently lost a long and drawn-out patent battle with MIT and Harvard's Broad Institute over the ownership of this technology. What's been your reaction to this?
Well, Emily, I think this is a common theme in areas of technology where there is extraordinary opportunity. There are always disputes about intellectual property, and CRISPR is no different in that regard. I'm proud of the fact that UC Berkeley, University of California, retains more than 45 issued patents that are not part of the interference. So we have a very strong intellectual property suite around CRISPR, and we continue to do our work at the Innovative Genomics Institute and with our partner companies. We're not impeded in any way by that ongoing dispute.
So on that note, how does this impact your efforts to, and your dream really, to commercialize this technology and apply it to hard problems for generations to come?
Not at all. I recently had a wonderful conversation just last week with Victoria Gray. She was the first United States resident who received a CRISPR therapy for her sickle cell disease. Just incredible to talk with her and hear about the impact on her family, her life. She's now enrolling in business school, something she couldn't have imagined doing when she was dealing with the ongoing impacts of sickle cell disease. And I think that's the future for CRISPR. We're going to see more and more opportunities to change people's lives in a better way, for the better.
So talk to us about your near-term goals and your long-term goals on the therapeutic roadmap.
Well, near term, I think we're on a path to continue expanding the kinds of applications that CRISPR will be used for, not only for very rare disease, but I think in the future using it as a way to protect against disease. And there already are companies, for example, Verve comes to mind, that are on that same path. And I think then farther down the road, I think CRISPR eventually becomes a standard of care for certain types of disease. I think that's something that I can envision. It will only happen if it's developed with an eye towards sustainability. It has to be affordable. Victoria Gray's treatment was close to $2 million. So clearly we need to bring down the cost. And we think that one way to do that is to do the kind of research that we have ongoing at the Innovative Genomics Institute, and then partner with companies when it makes sense.
And what's your outlook on the future of biotech returns? I mean, for so many years, this was an underinvested in part of the tech landscape, certainly when you compare it to consumer and enterprise technology. Do you see a new era for biotech investing being ushered in over the next decade?
I do. And part of the reason, one thing I think is driving that actually is the intersection of biotech with other kinds of technologies, hard tech, for example, computer science. I think many of us see that there are amazing opportunities when these areas of technology converge. And that's what we're seeing right now. So I think the next decade in this area will be very, very exciting for scientists and also for investors.
So where are the next big bets? Where should investors be putting their money quickly?
Well, one area I would recommend looking into is agriculture and synthetic biology. These are areas where we need CRISPR and we need other technologies to address the challenges of climate change, of a growing population on our planet. How do we keep people fed with high nutritional value crops? CRISPR will play a big role there.
So, profile, summary, final notes, and references. Summary: CRISPR-Cas9 has redefined genetic science, providing solutions to medical and environmental problems, yet ethical responsibility must remain central to its progress. So, final note is science without conscience is the ruin of the soul. Ethical integrity is the backbone of every technological breakthrough. So, references: World Health Organization 2024, Human Genome Editing Registry, UNESCO 2023 Ethical Framework for Biotechnology, and Nature Biotechnology 2023 CRISPR Ethics and Applications, and the future of this.
So the second emerging technologies is the robotic and automations. Robotic and automation involves smart machines that perform human tasks. With an AI integration, robots appear not only in factories but also in hospitals, schools, and homes. However, this process raises ethical issues related to job safety and decision making. So we must balance innovation with responsibility. And our mission is to advance robotics that enhance human capability while staying ethical. And our vision is a world where humans and intelligence machine coexist harmoniously. Then, objectives include understanding robotics impact, ethical issues, international laws, and responsible innovation. The first industrial robot is the Unimate on 1961. Automated factory tasks. Today, robotics is at the heart of Industry 5.0, combining human-robot collaboration. So, robots have evolved from simple machine into intelligent partners. So, let's watch the video.
Hey everyone, today we are diving into how robots decide to be honest, fair, safe, and environmentally responsible by saving our future. These values are key to making sure robots truly help people and the planet. Let's jump in. First up, honesty. Robots to be trustworthy, they need to communicate clearly. Take self-driving cars as an example. If a sensor fails, the car must report it to the driver immediately. In surgeries, robots like the Da Vinci system also need to be transparent. If there's a malfunction, it must report it to avoid deadly mistakes. Even robots like Pepper, used in healthcare, must be honest about their issues, whether it's losing a recharge or system update. Next, fairness. Robots must treat everyone equally and be accessible to all. In factories, robots must sell products faster, but they must ensure all workers benefit equally. And in healthcare, robots like Pepper assist the elderly, making sure that technology helps those who need it most. Safety isn't just about preventing accidents. It's also about minimizing risks. In hospitals, robots like Robear move patients safely, avoiding injuries. In factories, robots handle hazardous tasks, like lifting heavy objects, so workers don't have to. Finally, environmental responsibility. As robots get smarter, they need to be made from sustainable materials and be energy efficient. That means using recyclable, biodegradable parts and renewable energy, like solar power, to minimize their environmental impact. Imagine robots that help people, but also reduce waste and use less energy, leaving a smaller carbon footprint. Wrap up, robots are more than just technology. They're tools to create a better, safer world by making them honest, fair, safe, and environmentally responsible. We can build a future that benefits everyone. Honesty builds trust, fairness ensures equality, and safety protects us. And environmental responsibility ensures a cleaner, greener world. Thanks for watching. Together, we can create a responsible robotic future that's safe, fair, honest, and sustainable. Let's build a better future with robots!
Course Service 1. Industrial Robots. Industrial robots perform welding, painting, and assembly with efficient and safety. Tesla and Toyota use robotic arm to optimize car manufacturing. Low ISO 10218 safety standards. Impact. High productivity but job displacement. Robots improve speed but may threaten traditional jobs. Core Service 2. Service Robot. Service robots help in healthcare, education, and customer service. The Da Vinci surgical system assists surgeons with accuracy, and the robot Pepper interact with customers. Law EU AI Act in 2024. Impact. Better service but concern about empathy and privacy. Robots can help but they cannot replace human warmth. Course Service 3. Self-driving cars and drones rely on AI for minimal human input. Waymo and Tesla are leading in autonomous vehicle development. Law UN Regulation Number 157. Impact. Fewer road accidents but complex accountability. When AI makes decisions, responsibility becomes unclear. Poor services. 4. AI-driven automation powers smart factories using predictive maintenance. Low IEEE ethical aligned design. Impact. Efficiency improves but concern about bias. Automation helps industries but fairness but must be ensured.
And the fifth core service is the ethical governance and oversight. On ethical governance and oversight in robotics and automation, this ensures that the development of robots and AI systems aligned with moral values, human rights, and legal standards. As robotic system becomes more autonomous, ethical regulation is important to prevent misuse, unsafe behavior, and biased decision making. So ethical oversight helps guides in developers to create robots that are transparent, accountable, and safe for society. And so, for example, organizations such as IEEE and UNESCO promotes global frameworks that guides responsible robotics and ethical artificial intelligence. And the governing laws is one major policy is UNESCO's 2021 recommendation on AI ethics, which promotes fairness, transparency, and privacy protection and human oversight on AI-driven robotics systems. So then focus this ethical governance builds public trust and ensure transparency in AI and robotic systems. It, ins- it is reassures society that robots are designed to support human welfare, not compromise safety or rights. So ethical oversight ensures that robotic innovation remains aligned with human values. So for the code of ethics and the professional conduct, professionals in robotics must prioritize safety, accountability, and respect for human autonomy. A key example of this is the engineer following IEEE safety guidelines in designing collaborative robots. So the preamble is clear. Technological advancements must never compromise human rights or welfare. So the four principles is we operate under the four specific pillars. The first is the general ethical principles. We prioritize safety, transparency, and public well-being. And second is the professional responsibilities. We ensure reliability and protect data privacy. And third is professional leadership principles. We promote diversity and fairness in AI innovation. And lastly is compliance with the code. We abide by IEEE and EU AI ethics standards. So, a professional code ensures that we build technology with a focus in safety and human rights. And industry impact on takeaways. Nations like Japan, USA, and Germany create global robotics standards. Trends include emotional AI and human robot teamwork. The International Federation of Robotics reports 3.5 million robots operating today. So, robotics is rapidly growing and so must our ethical readiness. So, let's watch the video. So for the summary, final notes and references, robotics and automation significantly improve productivity and safety across various industries. However, they require constant ethical guidelines to prevent social inequality and misuse. And the final notes or final thoughts is that ethical innovation ensures technology serves humanity, not the reverse. Progress is only meaningful if it is remain human-centric. Then the references, the research from this section is based on the several key global standards, including the IEEE 2024 reports on the ethics of autonomous systems and the UNESCO 2023, the AI and robotics ethics framework, and the IFR 2024, the World Robotics Report. So, this responsible progress requires a balance between technical innovation and ethical oversight. So the third emerging technologies is the nanotechnology.
Nanotechnology manipulates matter at the atomic or molecular level to create new materials, devices, and systems with superior performance. It is widely applied in medicine, electronics, and environmental science, but introduces ethical concerns about toxicity, privacy, and equitable access to technology. Mission: to harness nanotechnology responsibly to improve health, communication, and sustainability. Vision: an ethical, innovative society where nanoscience enhances human life while protecting the environment. Objectives: to explain the principles and benefits of nanotechnology, to discuss its applications in IT and industry, to identify global ethical challenges in nanotech and IT integration, to promote responsible governance and sustainability. The concept of nanotechnology originated from Richard Feynman's 1959 lecture. There's plenty of room at the bottom. Progress accelerated in the 1980s with scanning tunneling microscopes leading to the modern nanotech era. Nanomedicine applies nanoscale materials for diagnosis and treatment. Example: lipid nanoparticles in COVID-19 vaccines deliver mRNA safely into cells. Governing laws: US FDA nanotech regulations guidelines. Impact: advances healthcare but requires monitoring of long-term effects. Nanoelectronics creates faster, smaller, and more energy efficient computing device. Intel's 3 nanometer chip enhanced performance and power efficiency. IEEE nano standards drives innovations but worsens e-waste and resource inequality. Nanomaterials aid in pollution control and resource conservation. Example: nanofilters purify water by removing heavy metals and bacteria. Governing laws: OECD nanotechnology safety guidelines. Impact: promotes environmental sustainability with potential waste toxicity risk. Nanotechnology enables smart sensors and communication systems that collect massive data. Example: nanosensors in medical wearables track patient health in real time. Governing laws: EU GDPR and IT privacy directives. Impact: enhances digital connectivity but raises surveillance and data misuse issues. Global ethics and governance. Global IT ethics ensures equitable nanotech use and knowledge sharing. Example: UNESCO's Nanoethics for Sustainable Development. Governing laws: UN Sustainable Development Goals impact strengthens global cooperation and responsible innovation. Code of Ethics and Professional Conduct. Nanotechnology researchers must uphold public safety, transparency, and sustainability. Preamble. The pursuit of innovation must be balanced with the protection of health, environment, and human rights. Number one, general ethics, ethical principle. Promote environmental and social responsibilities. Professional responsibilities ensure product safety and risk disclosure. Professional leadership principles encourage sustainable research and collaborations. Compliance. Follow IEEE, UNESCO, and OECD guideline. Industry impact and takeaways. International collaborations and challenges. UNESCO, OECD, and IEEE collaborate on safety and equity in nanotech development. Future trends. Nano AI systems, self-repairing materials, and green nano manufacturing. Statistical reports. The global nanotechnology market it is projected to reach $150 billion by 2030. Summary, final note, and references. Summary. Nanotechnology, when merged with IT ethics, can transform medicine, environment, and communication sustainability. Final note. Ethical awareness is the cornerstone of technological progress. References. UNESCO Ethics for Sustainable Development IEEE Nanotechnology and Society OECD Environmental Nanotech Standards.
So that's all. Thank you for watching and question and answer. But before we end, in summary, gene editing, robotics and automation, and nanotechnology are revolutionizing the world, but require strong ethical frameworks. As UNESCO states, science without conscience is the ruin of the soil. Ethics ensures technology serves humanity, not the other way around. So, thank you so much for watching of our presentation. Goodbye.